In this video, I wanted to explain the two physics concepts known as stress and strain. Once the force on an object is known, these two quantities can be calculated to give useful information. Something that you might not realize is that any object with a force exerted on it will undergo a change in length. Depending on the material the object is made of, this might be obvious or it may be difficult to detect. For example, picture a metal cable of length L hanging from the ceiling. If a mass is then placed at the end of this cable, it will become elongated to length L2. The change in the length of the cable is then known as delta L. For certain materials, the amount of elongation is proportional to the applied force, which allows us to write the following equation. This equation is known as Hooke's law, where K is just a proportionality constant. It's important to note that this only holds true for a certain amount of applied force. When plotting force versus elongation, most solid objects follow this typical curve. When a small force is first applied, objects will deform elastically, allowing them to return to their original shape when the force is removed. The amount of elongation will be proportional to the applied force up until a point known as the proportional limit. As the applied force increases, the elastic limit is reached, where the object begins to deform plastically. At this point, the amount of elongation can no longer be easily predicted. Any deformation to the object will also be permanent. As the applied force continues to increase, plastic deformation continues until the object fractures. For all of our equations, we're really only concerned with the elastic region since it's easily predictable. We can actually predict the amount of elongation that will occur on an object using the following formula. Here, F is the applied force, A is the cross-sectional area of the object, and L sub 0 is the original length of the object. E represents an important quantity known as Young's modulus. This quantity is dependent only on the material that an object is made of, and can be obtained from a reference table that lists various materials. The formulas for determining stress and strain are actually very simple. Stress can be represented by the lowercase Greek letter sigma, and is simply just the applied force divided by the cross-sectional area. Strain can be represented by lowercase epsilon, and is simply just the change in length divided by the initial length. If you solve the delta L equation for Young's modulus, you would see that Young's modulus is just simply stress divided by strain. If we graph stress versus strain instead of graphing force versus elongation, we would see that the graph would look pretty much the same. This is actually more useful because the slope of the elastic region is then equal to Young's modulus. These equations are valid for an object that is either in tension or compression. For an object that's in compression, the elongation will be negative. In my next video, I'll explain another scenario that involves shear forces. I hope that this video was helpful in explaining elasticity of materials and how you can calculate both stress and strain. If you still have any questions, feel free to comment below and I'll do my best to answer them. If you did find this video helpful, please give it a like and consider subscribing to the channel for more fast physics videos. Thanks for watching.